So for our homework, we're supposed to verify the mean and variance formula of a standard normal distribution curve. And the formula for a standard normal distribution curve is 1 over the square root of 2 pi variance, and the variance is inside square root, times e to the negative, the negative quantity of x minus the mean squared divided by 2 standard deviation. And so the way they wanted us to calculate that equation is to use the moment generating function. So you can take the first moment, take second moment, and the way they wanted us to do that is you need to write that whole equation I just told you in terms of e to the tx with t's in there, and take the derivative once and set t is equal to 0, and then you could get what e of x is equal to. So going through that process, I'll show you what I did over here. Taking e to the tx, or putting e to the tx into that function, you would get e, and taking the integration, of course, you'd get e to the power of mu t plus 1 over variance t squared. And then taking the first derivative, which requires some calculus, it expands out to be, using the product rule, mu times, mu is mean, it's mean, by the way, which we could verify in this formula, is mu times e to the power of mu t times e to the power of 1/2 sigma squared t squared plus e to the mu t times sigma squared t e to the power of 1/2 sigma squared t squared, which simplifies down to mu e to the mu t times e to the 1/2 sigma squared t squared plus sigma squared t e to the mu t times e 1/2 sigma squared t squared. And then taking the second derivative of that, which requires some triple product rules, in which I was unsure, I don't have like an answer key to step me through this. I took it slowly, and I got, I'm going through a little bit of work here. I got, mu e to the mu t times sigma squared t e times e to the 1/2 sigma squared t squared plus mu squared e mu t e to the 1/2 sigma squared t squared plus sigma squared times the whole quantity of e to the mu t times e to the 1/2 sigma squared t squared plus t mu to the e to the mu t times e 1/2 sigma squared t squared plus t e to the mu t times 1/2 sigma squared times 2t times e to the 1/2 sigma squared t squared. And then simplifying it down, I factored out some common like terms, made the first derivative very simple by just doing e to the mu t times e to the 1/2 sigma squared t squared, since that was a common factor in all those, times the quantity of mu plus sigma squared t. And then doing with the second derivative, I factored out all the common factors, and I got e to the mu t times e to the 1/2 sigma squared t squared, which is common factor out of all those, times the whole quantity of mu squared plus sigma squared plus mu times quantity of t squared plus 1 times t plus t squared sigma to the 4th power. And so they wanted to verify what the mean and the variance of those two formulas. And now the mean, when you set the first derivative, the e to the mu t times e to the 1/2 sigma squared t squared is equal to mu plus sigma squared t. When you set that equal to 0, all the t's equal to 0, you would get e to the x. And so when we set that to equal to 0, we get e to the 0th power, which just simplifies to be 1, times e to the 0th power, which simplifies to be 1 again, times mu plus sigma squared times 0. And then with some simplification, this goes to 0, this goes to 1, this goes to 1, and we just get mu. So we find out with the standard normal distribution curve on statistics that the mean of the standard normal distribution curve is mu. And then if you take the second derivative, this big long thing, and we set all the t's to be equal to 0, we get sort of the same outcome where we get e to the mu t to the 0th power, it's just 1, times e to the 1/2 sigma squared times t squared, that goes to 1 also. And then we get mu squared plus sigma squared plus mu times t squared plus 1 times 0 plus 0 times sigma to the 4th power. And that whole thing goes to mu squared plus sigma squared. And that's not the variance formula right there. To calculate the variance, you need to take e to the x, the expected value of x squared, which is the second moment generating, second moment generating function, minus the first moment generating function, all evaluated at 0, will give you the variance formula. And if you've already taken like a lower division statistics class, they say that the variance formula is sigma squared. So evaluating this out, we get that mu squared plus sigma squared for this part. So we get mu squared plus sigma squared for this part, minus, that's supposed to be squared, e to the expected value of x squared, and we get expected value of x is mu squared, so we get minus mu squared. These two cancel each other out, just getting sigma squared. So I am pretty confident now. I knew these answers beforehand. These are common statistic things you would analyze. I wasn't sure if all this work in between is right, but since this all came out right, I'm pretty sure it was right. And that's my math homework.